Once you get introduced to functions, there's no way out of it, and in this one page, I'll try to convince you that it is going to be worth it. But before we begin, a function is the rule that assigns a member from the set A into only one member in the set B. So what that basically means is this thing. This thing is a function. It is a rule that assigns a member out of this set we call X into the set we call Y, and only one member for each X we get specific Y. But why do we care about functions? Well, that is because of modeling. And what does modeling mean? Connecting the real world to mathematics is what modeling is all about. For example, I'm working in a field that requires me to record the temperatures of a substance. So I went in there and I took the temperature of the substance at time 1 a.m. and it was equal to 24 degrees. I checked back in at time 3 a.m. and it went up to 27. At 5 a.m. it became 30 degrees, and at 7 a.m. I checked back in to find the temperature at 33 degrees. This here is a function. Why? Well, because for every member of the set T, I assigned a value of the set temperature. But this here is a different representation of the function. And what I was describing before when we were recording the temperatures at different time frames, well, that description was also a function. And in fact, there are 4 ways in which we can describe a function. And those 4 ways being verbally, as I did a moment ago when I was describing that I checked at 1 a.m. and the temperature was equal to 24. And I checked at 3 a.m. the temperature was 27, and I checked at 5 a.m. the temperature was 30, and I checked back in at 7 a.m. and the temperature was 33. This is a verbal description of the function. The second way of representing functions is numerically. In this table we see here. The third way is visually, using a graph here, and the fourth way is algebraically. We use the algebra notation to describe a function. For example, y equals to x squared. In this case, for every input, the input gets squared and results in the output. What I did here was verbal description, was converting the algebraic description of the function into a verbal description. And I can also convert the algebraic notation into a numeric notation by plugging in a bunch of values. For example, I'll plug in 0 and I get y equal to 0. This is x and this is y. I'll plug in 1 and I'll get in return 1. I'll plug in 2 and I'll get 4 because they get squared. So these 4 ways of describing functions, we can convert them into one another. And for a fact, we can describe every phenomena in the world using functions. And there are different types of functions, each for different cases in describing the world around us. So one infamous function is the linear function. For example, here, this table describes a linear function. A sinusoidal function describes, for example, the movement of current inside an electrical wire, or for example, the movement of waves in the ocean, they come and go. For example, I'm working with physics, I'm working in a field and I have to analyze the movement of Earth around the sun and around itself. And I have read about functions and I want to analyze that movement. How I would go about doing that is that I will record the speed of rotation of the Earth around itself at different time frames, at different moments in times, at different time frames, at different moment in time. I will record the values in a spreadsheet. I will go ahead and graph a function to get an idea of how does the movement or the speed of movement of the Earth changes when it rotates around itself. Or for example, I will record the location of the Earth around the sun and the distance between it, the temperature of the sun, and in fact we can record just about anything that our hand can reach. We can record different types of quantities in physics, and using functions and mathematics we can analyze them. We can now begin to do operations on functions to get an idea of how those quantities might change and their interaction with one another. That's why we call mathematics the language of the world. We also can make predictions using functions. Well, in this case, at the time 1 a.m., my temperature was 24, and at time 3 a.m., my temperature became 27. 5 resulted in 30, and at 7 a.m., my temperature is at 33. So at 9 a.m., we can predict that my temperature will be 36. So functions can help us with prediction also. So this is the connection between the real world to mathematics. What makes that connection possible is functions. Once we modeled phenomena in the real world into a function, we can now go ahead and do operations on functions to learn about stuff regarding that phenomena and to learn about the world around us more. So this is the power of mathematics, and this is what we use functions for.